What kind of experiments will we be running in the world's first hyperbaric biosphere? Well, behind me is the huge chamber, 62 feet long, weighs 92,000 pounds. It is 5/8 inch steel with special acrylic windows and special seals for the protection of the monitors, the technicians inside, and for the public outside. Now, the pressure in this biosphere will not be elevated that much, not nearly as much as you have in the tires of your car. In fact, the pressure will just be about 1.5 atmospheres of pressure. We have 14.7 pounds per square inch. We will run it up to about 22 pounds per square inch and about 25% oxygen. Now, the 25% oxygen under this kind of pressure solves major problems. That answers the dinosaur problem. Behind me is a large Acrocanthosaurus dinosaur footprint that we excavated in north central Texas. That creature would have stood over 16 feet tall and would have been over 40 feet long. Acrocanthosaurus had one of the largest brain-body ratios among the dinosaurs. Now, one of the problems with the dinosaurs is that their body mass under today's atmospheric pressure and under today's oxygen ratio could not get enough oxygen assimilation to feed the deep cell tissue of their bodies. But under 1.5 atmospheres with 25% oxygen, slightly higher carbon dioxide ratio, etc., that solves the problem because the entire blood plasma under those conditions becomes saturated with oxygen. But now we're going to introduce another experiment. I've mentioned in the past that we're going to introduce flying squirrels who will navigate through the greater atmospheric pressure with greater ease, bumblebees, dragonflies, butterflies, who will be able to navigate so much better under that kind of atmospheric pressure. But as we look in the fossil record, and our team has excavated to date components of 19 different dinosaurs in 2 states, and we've also excavated in Israel and South America. As we excavate along the banks of the Paluxy River in these Cretaceous layers, we find numerous indication of lycopods. Those are like club mosses, lycopsid club mosses. They are hollow inside with heavy root systems, tentacles of those roots that run tens of feet, and yet they ran sometime up to 120 feet in stature. Now, this solves some major problems. In order to generate the appropriate amount of oxygen in the atmosphere, you need some very large plants in great billions in numbers. Well, if the coastal lands, the waters of the coastal lands, were saturated with these water-friendly plants, and if some of the mysteries of the fossil record, like fish-like creatures that apparently had legs, not fishes, but fish-like creatures with legs, this would mean that they would be needed to run over the roots and around the roots and over the top and back into the water. So the entire ecosphere is balanced again. In the biosphere, we're going to pay special attention to the growth of these lycopods, these reeds that are hollow inside, that float in the water where they're growing, yet produce very large amounts of oxygen. The creation model really makes sense.